Okay, so actually, me and Stefan, with this work, we have tried to use the large language model as a somehow at the beginning as a technology to assess biases from the classified publications in three main bibliometric databases, and I will go through a very quick background. So, yeah, so the motivation starts like considering that bibliometric databases are actually playing critical role in general. In sociology of science, they are somehow they are influencing all the behavior, so not all, but at different levels, behavior of academics, researchers, funding institutions, policy makers, and but of course, on the other hand, they respond like to political and commercial interests that might be at so at different levels, and then they have a somehow performative nature. Web of Science, Scopus, and OpenAlex have been the three main bibliometric databases that we considered, and we're relying on a previous work that was on the labeling of SDGs, so how search inquiries are drafted, and already at that point was seen a very little overlap of these publications. So. This is a bit like what I already mentioned, so that we're looking at somehow aggregate effect that we can have from like like the metadata somehow that are processed by the at some levels from the bibliometric databases, and how it comes to maybe a researcher or a policymaker or a consultant. And then LLM, so like the last aim of this project was to draft like a pretty general exercise in order to also to assess, that's why like aggregate effect, to assess how it might be impacting, like in this case, research policy. And yeah, this is very briefly like the chain of dependencies that we considered, and somehow we're considering like the LLM, changing the metadata, so what is called research on SDG, and that would be impacting then like many advices, choices, indicators, and measures. So the actors that we consider, as I said, are the two proprietary Web of Science and Scopus, and the open source, freshly open source, OpenAlex. And then we consider 5 SDG in order to, actually the choice come from trying to model like socioeconomic inequalities part of, and so we chose like 4 about education, gender equality, and reducing inequalities, and these 3 about equity, and the other one is the economic dimension. So we consider like a shared corpora of all the publications, and so we applied then. We performed then their classification directly, not on all their database, but on the shared corpora, in order to have somehow a benchmark. But this is the first results that we got that are pretty that are totally in line with the main. The main results from Armitage 2020 that we were coming from, so that in that case the labeling of SDG were very they had a very small overlap, and this is you can see this also in the publications. So here I'm showing like the overlap that we have of all the publications separately, classified by the bibliometric databases. But for example, like how to say, like these publications are also from Scopus. It's just that Scopus is not considering them as SDG5. Also, yeah. Also, Web of Science is considered a lot, like 10% of the publications, they come from mathematics in SDG5. So like geometrical differential equations, so something might be missing. And yeah, here it comes the way in which we model the LLM technology. So we tried. We started from the idea of like having only large language model that was trained only on on the corpora of publications that were classified by that bibliometric database, that specific SDG, and that would be like one of this circle somehow, and. Of course, like setting up out of scratch was would have been very committing, but the compromise that we found was like to fine tune somehow an existing LLM, an open source one that is Distill GPT-2, that is very basic, but also on the other hand it has very little knowledge. And compared to maybe commercial or large open source ones, we somehow have the proof that is no prior knowledge about the semantics that is around both publications or prompts. And yeah, as also Arno mentioned yesterday about like there is a huge difference in parameters, and one of the main things is that it's very much so it's little extracted and might be like a drawback, but also in this case as the fine tuning has been for similarity, so we gave for fine tuning only title and abstract. It's so like the prompt is actually a new title and it's drafting another abstract, so a new abstract. Okay, every SDG has is done of targets. This is an example for SDG4. Usually are between 8 and 12 among the ones that we considered, and that is what we relied on for drafting the prompts, and somehow at the same time I've seen it as a attempt of validation of more than validation of a benchmarking. So as I have prompts that are on the targets, I can consider then if the LLM is not replying to my prompts somehow, so I can consider like ground zero. They should reply to the prompts as it is on the targets, as it is actually what the SDG is asking for, and if it's not replying, information is missing. So said very roughly. So then I use that as a somehow standard for compliance with SDG and biases. And yeah, this is very this is a schema of what I've been saying up to now until the second row. Then the prompts that are like specific for every SDG, they go through 3 different decoding strategies, and then then I do like for simplifying like unknown phrases extraction, but also when I'm doing the comparison, I'm also looking through searching through the actual responses. this is so this is illustrative for SDG4, but you can imagine this for all the SDGs. Somehow I drew a table and I could distinguish which targets and which targets were addressed and which not, and somehow like which were the biases that might be or might be not considered also indirectly with the targets. And we found somehow like four main dimensions that are locations. For example, all the targets in all the SDGs are mentioning locations, actors, that the data and metrics is mainly part of the LLM response, and and focuses they are like SDG specific. So this is somehow one of the main results I consider, that for example, for SDG 4 we have the LLM that is not addressing like locations that are mentioned in the targets, like the most sensitive actors, so most sensitive categories of actors, and also the most sensitive focuses that I might be considering that also the SDG is on. And this is somehow why I showed this, because somehow it's like a kind of recurrent result that I found all over, that we found all over the 5 SDGs. And there was yes, for locations, but on the other hand, we have like, for example, United States, that it's always mentioned for every SDG. South Africa and China are the one just after. In actors, we have for different SDGs that like the same discriminated categories are asked for, and there is no macro response. In metrics, yeah, we got a lot of so many different surveys that are recalled as data set. So somehow like in the semantic multi-layer networks that is behind after the fine-tuning, there are some like recurrent data from surveys. And also another remarkable result was that for example, for like 3 different SDGs, you could you could distinguish a very theoretical approach by Web of Science and way more empirical one from the other 2, Scopus and OpenAlex. And yeah, so this is somehow just a roundup of findings that is so like I would say that the main result was this systematic overlook in the data about the actors that I mentioned, poorest countries and the unrepresented topics. And yeah, of course, like there are many limitations that might be considered in this, starting from the fact that it's a very general framework. So it might be that in any very specific applied cases, something is changing, but I'm also not super sure about. And it is somehow, yeah, so like, we have a high sensitivity in general with LLMs so in particular on the training data. Then model architecture can change or not, and then there are like also calibration parameters and decoding strategies. And somehow we can consider to some extent that training data and decoding strategy has been accounted. So training data, considering that there were 3 different databases, so like kind of And the decoding strategy, we use 3 different decoding strategies that were in literature. And yeah, I'm done. Okay.
Thank you very much. So the floor is open. I will occasionally check in the chat, but so far there's no comment. Yeah, could you maybe to Malte? Yeah.
Thanks a lot. I give you some time to drink. I have a question of understanding. So are you basing your work on the title, abstracts, full text, and then, so to say, one of the like 2 slides back also, there was this comment on the different, I don't know, one on the methods that the different public database providers have for tagging something. So is that something that you now see in a different way with the use of LLMs? So do you detect the systematic bias? And so 2 questions. 1, what text are you basing your work on? And 2, biases.
Oh, yeah. I'm actually working only on title combined with abstract, and but also I double check if something would have changed that much without titles, and actually it wasn't a relevant variation. And secondly, this is what so like I don't so like I consider systematic like with respect to the specific SDGs that we considered, and still in the specific conditions, because we're still talking about tools that can for example, we proved at the beginning of the paper that like with different calibration parameters that are bringing to same performances metrics, not in the content, but from the computer scientist perspective, you still have an abstract that is very convincing, but mentioning different countries or maybe not an empirical, not a thematic analysis, but maybe I don't know, a DSG in macroeconomics. So it might be so varying like that. So I would say, but so it's systematic only with respect to these specific conditions and this SDGs that I found. But yes, you could see Web of Science way more on the theoretical approach. So like, for example, mentioning methods or having, because of course, in the known phrases extractions, you get a lot of terminologies that are coming from academic speech in general. So, but then, it has also a relevance frequency-wise. So if theory is mentioned like almost all the times in the some kind of models, and so this is something that might be assessed. And yes, of course, I would say that so like a tool like that used in the might be like might be favoring more one side, one approach rather than another. So
thank you. The next one will be Andreas. He's right there.
Thank you for the presentation. Maybe my question is a bit too general, and maybe you're not the best person to direct the question at, but I still want to mention it anyway. Just like we know that the general internet is not only being polluted with AI-generated text, but it's also being purged of valuable research information. Are you worried that these bibliographical databases are in danger of being purged because institutions or authors retract articles with keywords like sex, gender, race, and these kinds of things for fear of losing funding, or maybe even the database providers start trying to comply with these new policies. Are you worried about this? Thank you.
To my limited knowledge about the power dynamics that are in the science scholar networks, I think that already like having a newcomer like OpenAlex that is that is talking about open science and having like a different perspective rather than another. It's like indirectly showing that this kind of interests, I think, are already there. So I'm sure that retracting papers might be impacting, but I also think that on the other hand, them as like as digital infrastructures very prominent. So like this kind of political and commercial interests are already there, and somehow like with policymakers and funding agencies, I think there are interrelated relationships that they might come.
Hi, my name is Maeve, and I'm one of the people that's less experienced in this field generally, so excuse the elementariness of my question. You're looking at such a big field. I mean, you're looking at 5 different SDGs, you're looking at the sub-targets, you're looking in these 3 different databases, and looking at the aggregated effects. I'm just wondering how much you can take away from what your final product is. Like, what is the nuance that you feel like maybe you lost by trying to have these aggregated effects across aggregation? Is there like things that popped up that were interesting, or that you just feel like you sort of missed by putting it all together? Maybe you can answer that, maybe not.
I think that this kind of aggregations can be monitored in the in this schema, and because like I use some thresholds, so in particular at the end. So like when I'm doing like the word filtering coming from the decoding strategy, but still, so we're not talking about a huge number of texts. So because like the prompts and then the responses are, let's say this is what's happening for one bibliometric database and one SDG. SDG 4 has like 8 targets, and then I drew 80 prompts, so 10 prompts per target, and then I use it here in 3 different decoding strategies. And I can assess with a very low threshold all the num phrases that I have from the 3 of them. And still, on the top of that, I also go through when I go through the responses when I'm missing something in the when I'm doing like distinguishing like addressed and not addressed SDGs. So I think like this aggregated effect that I was meaning was not very much like in the quantitative perspective, because they are not so many, and the threshold is like a kind of 2%, and then like in 10 prompts that are on the same target, if you couldn't reach like the 2%. So this is the aggregate in the end. So it's at 2%. It's a very, so a prompt, so like a target is like the prompt is just like turning around the same sentence. And so if it's not replying with a greater than 2%, I would say I can start like considering that maybe there is not signal enough in the data. Also because like on the other hand, for other things it replies. So.
Thank you. There's one more by Adrian, but raise your hands if you have comments. I will see you then.
Okay, thank you. Perhaps I'm mixing things up or I missed something, but am I right in understanding that you used LLMs to detect biases in the bibliographic databases, right?
On the only on the publications that that bibliometric database has classified as, for example, SDG4.
Because I just thought it's interesting because usually we're concerned with the biases in the LLMs, right? But sort of you use it sort of the other way around. You use this to detect biases, and isn't there the problem that you don't know whether the LLM itself has biases as well?
I think I think it's like for me it's a follow-up of so the LLM is so I think might be sometimes ill-defined. Like for example, when they started talking about ChatGPT that had like racial biases, I'm really skeptical calling them racial biases because it's coming from all the corpora that has been scraped from the web, and the web is full of that, and that perspective is that shared corpora. So then it came like human feedback, so double feedback, reinforcement learning, everything, but it's just normative. So you make, but I think that was like, so like these architectures are replying the data that you give them, and so that's why I feel that these biases are, so it's the main thing that you get from,
Thank you. There's Fenna next.
Yeah, thank you. I wanted to ask about where the biases are. So you've detected them in the bibliometric database, but do the data that you get out of this tell you anything about what the source of the bias is, whether it's academics aren't writing about this or English language academics aren't writing about this, or is it downstream from funding agencies not being willing to fund these things, or it's because actually think tanks and charities are doing the writings on human trafficking or things like that? Thank you.
Yeah, I appreciate a lot, but as you can imagine, this might come like a very big network where to look at. I think so. It might be so. I see it like as an accountability chain. So you can see like the bibliometric databases have a northwestern bias. But it's because like the research that has been classified, or in general, the research that they have within, it's in the end like mostly Northwest, or it's because like in the last few years, a certain topics has been like called for funding in a certain way, and so I think that is like, it's a kind of complex system. So I can't see very, so I would say I can see that in this way of classifying there are these biases, but like beyond that it's it's somehow like the dynamics of science that is behind this, I think.